Hello and Assalamu alaikum everyone. My name is Arsalan Farrukh and I teach math and physics. In this video, I will discuss with you how to sketch the graphs of inverse functions. We've already discussed that when we find out the inverse function, it just is a process of interchanging domain and range. So your domain becomes the range and the range becomes the domain. Which means if you have a particular point on a function which is originally a and b, then on the inverse function it will become b and a. So this is something you can use in cases where you know an original point on the graph and you have to find out the point on the inverse function graph. You can directly flip the x and y's. Like for example, if you know that there is a point on a function which is 4 comma 0, then on the inverse function it's going to become 0 comma 4. And similarly, if there's a point which is 0 3, that's going to become 3 and 0. So this is something that you can use in a lot of situations, but eventually you'll find out that after you sketch the entire graph, it will come out to be a reflection in the line y is equal to x. So another quick way of sketching the graph of the inverse function is just reflecting the graph of the original function in the line y is equal to x. You can represent the line y is equal to x as a broken line segment, and then you can reflect the original graph in this particular line, and that will get you the graph of the inverse function. Let's have a look at few examples of that. Like for example, if I know that this is the graph of the function and I have to sketch the graph of the inverse function, so I can make a line y is equal to x. Ideally make it as a broken segment over here, which I haven't done here, but please make sure you do that. Anything which is not considered as part of the graph should be represented as a broken line segment or a broken curve. If you know that this is the graph of the function, then its image is going to be the reflection of this graph. So you can just see that the reflection of this point will go over here. You just make a mirror image of the original function, and hence you can sketch the entire graph. Similarly, if you have a graph which is like this and you wish to sketch the graph of the inverse function of that, then you again draw a line y is equal to x, and you know that you're going to reflect it along this line. So the point where the function and y is equal to x intersect, that point would remain unmoved. That point will remain where it is. Similarly, if you see that graph of a particular function is exactly symmetric about the line y is equal to x, so that means its part below the line is similar to the part above the line. In that case, you know that after reflection it's going to remain the same. So that means that the graph of the function would be same as the graph of inverse function. And of course, the function will remain same as well. An example of that would be that if you have original function as 1 over x, and if you follow the basic steps of finding out the inverse function, you will find out that the inverse function also comes out to be 1 over x. So that will mean that the graph of function and inverse function and the equation of function and inverse function would be exactly identical. Also, please remember that if you have a graph of an original function and you use that to identify an information about the inverse function, you can do that in terms of domain and range. You already know that the domain for function turns into a range for inverse function, or a range for function turns into a domain for inverse function. So whatever is the range of interval of domain for a particular function would be the range for inverse function. Let's say your domain for a function lies between 3 and 7, and your range for a function lies between 0 and 10. So then you will know that once you'll find out the inverse function, the domain will become 0 to 10 and the range is going to become -3 till 7. So that's how you can find out the domain and range of the inverse function directly by looking at the domain and range of the function. Also, one more thing that can be of use. Let's say the function is given to you as x plus 2 upon x minus 1, and you're being asked to solve an equation fx is equal to f inverse x. And this might make you think that you have to go through a long process of first finding out the inverse function and then equate the two to find out a corresponding domain. but yeah, you can have a shortcut because you know that wherever function and inverse function meet, there's also another line that is going to be passing through that. So where the function is equal to inverse function, they both are also equal to y is equal to x, which means if I have to solve this particular equation, I can just simply solve this equation by writing it down as fx is equal to x, which means I will write this equation as x plus 2 upon x minus 1 is equal to x. And then I'll solve it for x and I'll get that value of domain for which function and inverse function are equal to each other. So guys, that's it for this particular video. I hope it was helpful to identify how to sketch the graph of the inverse functions and how to use that graph to find out the domain and range. If it did help, I would really appreciate if you would give a thumbs up and also subscribe to my channel.